In this video, we're going to learn how to determine the median, the lower and upper quartiles, and some percentiles. And we have an example that we're going to use for this purpose. So we have the data below shows the number of bags of maize taken to a corporate society depot by 100 farmers in 1 week. Then we're given the number of bags and the number of farmers. And you're required to calculate the median, the lower and upper quartiles, and the 80th percentiles. So the first thing we're going to do is create a table. In this table, there are 3 columns. The first column is the one with the class, and the class is obtained from the number of bags. And then the second column is for the frequencies. And then we are going to have a third one for the cumulative frequency. So let us go ahead and do that. So the table looks like this. The first column is class, which you have just obtained from this first row, which has got the number of bags. And then the second column is the frequencies, which is just the number of farmers. And then we're going to create a third column, which is cumulative frequency. We just add the frequencies across the timelines. So the first frequency there is going to be 18. The next one is now 18 plus 26, which in this case is going to be 44. The third one is 44 plus 30, which is 74. Then the next one is 74 plus 7, which is 81. Then plus 1, which is 82. Plus 5, which is 87. Then plus 4. Plus 4 is going to be 91. Plus 2 will be 93. Plus 5 will be 98. And then plus 2 will be 100, which is the total amount of frequency that we have. And the next thing is now to go into the first equation, which requires us to obtain the median. So before we obtain the median, we have to identify where the median lies. So how do we know that? We know that by dividing the data into 2 halves. So it is 100. If you divide it, it's going to be 50. But being an even number of terms, the median is going to lie between 50 and 51. So it is in between this. So it means you're going to obtain the median for the 50th farmer and the median for the 51st. So the formula we're going to use is as follows. The median is going to be given by L, where L is the lower class limit for the median class. Then you're going to add that to N over 2, where N is the total number of frequency, and then minus C, where C is the cumulative frequency above the median class. And then we have I, which is just the class size or the class interval. And then we have F, where F is just the frequency of that median class. So let us identify each of these items before we can solve for this. So first of all, let us get the one for the 50th farmer. So according to the cumulative frequencies, 50 lies in this class because it cannot be in the first one. This one is 44. So this one has got up to 44, but the next one has got up to 74. The next one is even higher, 81. So it means 50 and 51 lie in this class, the 25 and 34 class. So we identify what we call the median class. The median class. We do this because all of these items here are going to be in reference to that median class. So we have the median class as 25 to 34. 25 to 34. So we have the median class. So now we can go ahead and solve for the median for the 50th farmer. So we say for the 50th, we're going to have L, and L I said is the lower class limit in the median class. So the median class, the lower class boundary is 25. So the lower class limit is you minus 0.5 from there, so that you have 24.5. That is for the median class. Then plus n over 2. So it is the 50th. So we just write 50. Now minus C. C is the cumulative frequency above the median class. So this is the median class. So above it, the cumulative frequency is 44. So we say minus 44. And then over F, and like I said, F in this case is the frequency of the median class. And the frequency of the median class is 30 in our case. So we write 30. And then you close that in a bracket, and then you multiply by the class interval. So the class interval is just obtained by taking the difference between the upper and the lower class limit. So we can even use this median class to do that. So the upper class limit here will be 34.5. So we have, so I will be equal to 34.5 minus the lower class limit for this will be 24.5. So minus 24.5, and you'll find that to be 10. So it means I for this set of data is 10. So we multiply this by 10. So let us simplify that and see what we get. So this is going to be 24.5 plus 50 minus 44, that is 6. So you have 6 over 30 times 10. So if you simplify that, you're going to find this to be 24.5 plus, if you simplify 6 over 30 times 10, that is 2. So it means we have for the 50th farmer, we have 26.5. Then we look for the 51st. So for the 51st, we're going to have not M, but L, which is the lower class limit for the middle class, and we found that to be 24.5. Now plus N over 2, but now it is the 51st. So just take 51 minus C, and C in our case is 44. And that is over the frequency for that median class, which we found to be 30. And then this is what we multiply by the class interval, which we had found to be 10. So let us again simplify this and see what we get. So this will be the same as 24.5 plus this. This is 51 minus 44, that is 7 over 30 times 10. You simplify that and you get 24.5 plus the, if you simplify this one, you're going to get 2.3333. 333 recurring. So you can truncate this so that you have 24, not 24, but 26 point. This will be 3 plus that is 8, 3, 3. So that is for the 51st. So now we have the two of them. For us to get the median now, we just get the average of the two. So therefore, the median for this data will be given by the one we obtained for the 50th was 26.5. So we take 26.5 plus the one we obtained for the 51st, which is 26.833. And then we divide that by 2. So when we divide this by 2, that is when we get the median. So divide that by 2, you're going to get this to be 26.6666, which can be rounded off to 26.67 as the median for that particular data. Then the next question required us to obtain the quartiles. That is the upper and then the lower quartile. So let us start with the lower quartile. So let us slide that, and let us start with the lower quartile. The lower quartile is denoted by Q1. So for us to obtain this, we're going to use the following formula: L plus, remember the lower quartile is a quarter. It is a quarter away, they're all data. So I'm going to take a quarter of n, that is just n over 4, then a minus c. In this case, c is the cumulative frequency above the quartile class, or like in this case, the lower quartile class. Then we multiply that by the class interval, and then we divide by f, and f in this case is the frequency of the lower quartile class. So it means we're going to have to identify where this lower quartile lies. So for us to do that, we're going to take a quarter of the data. So the whole data is 100. So you're going to take a quarter of 100, which is just 25. So it means the lower quartile lies in the class with a cumulative frequency of up to 25. So let us go and look for that class. So you look at the table that we created. You'll find that the first one has got 18 as a cumulative. The second one has got 44. So it is not in the first one, it is in the second one, because 25, which you're looking for, is more than 18 and it is less than 44. So the 25th farmer must be within this class, that is 1524. So that is what we use. The class is 1524. So it means the Q1 class is the 15 to 24. It is the one that we're going to use in this case. So let us now start looking at the different parts, one after the other. So L in this case is just the lower class limit for the Q1 class, or for the lower quartile class. And then in that case, that will be 15 minus 0.5, which is just 14.5. And then N is the total frequency, and C is the cumulative frequency above this class here. And I, as usual, is the class interval, which we have obtained to be 10, and F is the frequency of the Q1 class. So let us just substitute these values so that we see what we have. So L is going to be 14.5 plus 100 over 4 minus C. And if we look keenly, we'll find that the C is the cumulative frequency just above the Q1 class. And we found that to be 18, because 18 is the cumulative frequency just above the Q1 class. So we just subtract 18. We can close this in a bracket, and then we multiply by the class interval, which we found to be 10. And then we divide that by the frequency of the Q1 class. And we have obtained the frequency of the Q1 class to be 26. If you refer to the table that we have. So let us simplify this. So we have 14.5. Then we simplify what is inside this bracket. That is 100 over 4 is 25. So we have 25 minus 18. 25 minus 18 is 7. So it is 7 over 26 times 10. So let us again simplify this. So we have 14.5 plus, if you simplify 7 over 26 times 10, you're going to get 2.69. 2.69 at 2307692. So when you calculate that, you're going to have 17.19230.769. So this is approximately, in two decimal places, that will be 17.19. as the Q1 or the lower quartile of this data. So the next is to look for the upper quartile, the one that is normally denoted by Q3. Remember, Q1 is the lower, Q2 is the central one, which is just the same as the median, but the upper quartile is the same as Q3. So let us look for Q3, that is the upper quartile, denoted by Q3. So Q3 again is obtained by L plus in bracket 3 over 4n. It is 3/4 of the data minus C. And again, C is the cumulative frequency above the Q3 class. So that is over F, where F is the frequency of the Q3 class. So let us obtain all of these values. First of all, let us identify where the Q3 lies. So we have 3 over 4 of n, and n is 100. You found that to be 75. So we look at which class does 75 lie from our table. Let us just slide that down and identify where that particular farmer lies. So it lies in which class? So it will be in the 3544 class, because the cumulative frequency of that is 81. We could have taken the previous one, but it's less, it is 74. But the next one is 81. So the Q3 class is 3544, and its frequency is 7, and the cumulative frequency above it is 74. So let us go back and use that information to solve for our Q3. So now we have identified that the Q3 class, is the class that is 35 to 44. 35 to 44. And we have also found that the frequency of this class is 7, and the cumulative frequency just above this class is 74. So we have all the information we need to solve for Q3. So let us just do the substitutions. So L, we are going to take 35 minus 0.5. So that we have 34.5. Now plus 3 over 4 times n is 75. So we have 75 minus C. And C is the cumulative frequency above the Q3 class, which we have obtained to be 74. So minus 74 over F. That is the frequency of the Q3 class, which we found to be 7. Then all of this we multiply by the class interval, which is 10 for this data. So we have 34.5 plus 75 minus 74 is 1. So that is 1 over 7 times 10. You simplify that, you're going to get this to be 34.5 plus, if you simplify the second part, you're going to get 1.4285, which you will simplify or will round off when you're done. 857.1429. So you add the two, then you're going to have the Q3 as 35.92. 35.92. 857.1429. So this is approximately 35.93 as our Q3. So now the next one is the 80th percentile. So percentile is just the data out of 100. And we are just going to do the same thing we did for the Q1 and Q3. So let us look at the 80th percentile. The 80th percentile. So the formula for the 80th percentile is going to be L plus into bracket 80% of the data. Data is N minus C, where C is just the cumulative frequency above the 80th percentile class. Then you again multiply that by the class interval, and then we divide that by the frequency of the 80th percentile class. So let us identify this. First of all, we have to know where the 80th percentile lies. So we just take 80 over 100 times the data, which is just 80. It is a coincidence that our data is out of 100. So we look for the class with the farmer number 80. That will be our 80th percentile class. Let us go back to our table and look for the class with the 80th percentile or the 80th farmer. So from the table, you can see that the farmer, the 80th lies in this class, that is the 35 to 44. And the frequency is 7, and the cumulative frequency above this class is 74. So those are the information that we're going to use in estimating or in calculating the 80th percentile. So let us go back to calculations and see what we get for the 80th percentile. So the data we have from the table is that the class or the 80th percentile class, we say 80th percentile class is 35 to 44, and its frequency is 7, and the cumulative frequency just above that class is 74. So that is the data we want to use in solving for the 80th percentile. So let us do that. So we just substitute in our formula. We have L, and L is the lower class limit. So we just take 35 minus 0.5, and that is 34.5. Then we add 80 over 100 times N is 80. So we have 80 minus C. That is the cumulative frequency above the 80th percentile class, and that is 74. Then we divide that by F, where F is 7. That is the frequency of the 80th percentile class. And then whatever we get, we multiply by 10, which is our class interval. Okay, so now let us just simplify this. So that is 34.5 plus 80 minus 74 is 6. So we have 6 over 7 times 100. So that will be 34.5 plus, when we simplify this, we're going to get that to be 8.571, 428,571. So you add the 2, you're going to get that to be, that will be 34 plus 8 is 43. So we have, not 43, that will be 42. Then there's the other one, 5 plus 5 will be 1. So we have, that will be 43.07142857. So that is approximately 43.07 as the 80th percentile. Thank you for watching. Please remember to subscribe.